We have parcel, we have sender order, we have receiver order, 3 aggregate roots with proper lifecycle and guards. No one of them have ever been saved to a database. So let's save parcel. Simplest thing, inject JPA repository, for example, ParcelJpaEntity who extends JPA repository directly into our use case, for example, order application service. Create method save and works done. Except now your use case has a direct dependency on JPA. Spring data is in your domain logic, and the fun starts when someone says, we want to add a second adapter, cache parcel lookups in Redis, or load from an event store instead of a relation database, or just write a test that doesn't need a running database. Every time you touch the use case, the question isn't whether it works, it does. The question is who owns what. Does your use case own the decision of how things get persisted? Or does it just say what it needs? That is the split. A repository is an interface in the application layer that looks like a collection of aggregate roots. The use case says what it needs. The adapter figures out how. Dependency arrows point inward. Use case depends on the port. Adapter depends on the port. The port depends on nothing outside the domain. If you want to swap the adapter, the use case doesn't change. If you want to test the use case, you pass a fake implementation of the interface. The use case doesn't know the difference. Let's create parcel repository port. So let's move to the our parcel package in the application port and out. So now let's create the interface parcel repository, create save method, so parcel JP like that, optional, parcel find by ID maybe. So in ParcelJpaEntity we have UID, so UID ID. And here we need find by order ID. So our order ID, it's UID2, so it's okay. Okay, so 3 methods, nothing about SQL, nothing about transaction, nothing about Hibernate. Just give me a parcel by this ID. The port speaks domain language, find by order ID, not find by order ID equals UID. 3 methods. Domain says what it needs. Now we build the thing that provides it. So first, move to the ParcelJpaEntity. And we have 4 problems here from the previous video. So now we need to remove generated value by UID because we generate this by function. Here we have generate, so UID is unique value. So we don't need a generation value in our entity. Okay, so now we need to add order ID. We need add. Okay, we need to delete setter from here. We create now builder. We add builder now, but in the future, where we want to create our own builder, not from Lombok. Okay, now it's look good. Okay, don't need entity who is dynamic model. We can create mapper from domain to our ParcelJpaEntity and from JPA entity to the domain. We can put them on the entity. We can create public static. So first we create from. So we put parcel, and now use builder. We add Lombok annotation. So now ID and parcel. I forgot to add our parcel. We need to add order ID. Order. Okay, now we can order ID. Okay, so now let's create toDomain function. So static parcel to domain from ParcelJpaEntity. So we have a restore function. We need to put the parcel ID. Okay, we create our two functions. So from domain and toDomain. Okay, now let's move and create parcel persistent adapter. So in our parcels adapter out, so where we have our ParcelJpaEntity, let's create parcel persistence adapter. Now Persi. Oh. Okay, and implements this is the connection. Parcel persistent adapter implements the port. So our port is ParcelRepository. Spring Modulith verifies that nothing in parcel domain imports from adapter. If something crosses the boundary, the module test fails at build time. So now we can inject ParcelJpaErepository. We not required a constructor, and we can implement the method. Okay. Now we can add a transactional on the function. Transaction is a persistent concern. The domain has no idea what a transaction is. We have a full episode on annotation transactional, link in the description. For now, it belongs here. Okay, so save simple transactional, find by is only read only. I import wrong transactional from here. Okay, import like that. Okay, so save is JPA-repository save entity. From here it's JPA-repository find by ID. Now map parcel JPA-entity to domain. Okay, I write here bad return because we need the domain parcel. Parcel. here and parcel here. So here it's found by order ID. Return its ParcelJpaEntity. Okay. So now let's create the parcel configuration. So parcel configuration will be in the parcel main module. So parcel configuration. Configurations. And now let's create the two bin. So public parcel persistence adapter, ParcelJPA repository, and inject to our persistence adapter like that. We don't have component auto-wired. Everything is handled by configuration. Why manual? Because when you read this class, you see exactly what depends on what. No annotation magic, no class path scanning surprises. Order application service gets a parcel repository and an interface. It never sees parcel persistence adapter by name. Okay, now we have parcel configuration. We can create in our order configuration. And now I can create a bin public order application service. So what we need to inject ParcelJPA repository. So ParcelJPA repository for now. Okay, but we use a parcel repository. Parcel repository. Okay, now we can move ParcelJPA repository here, and we need to parcel repository parcel repository. Okay, now we need to move our parcel repository. Parcel repository to the main package because Spring Modulith only public APIs needs to be in main package like parcel repository. Okay, try to run the application. Okay, we have a problem here. We need to create order ID generate. Let's put to the sender order order ID parcel ID. So we create here parcel ID to parcel ID generate. We can put here parcel ID. What do we need? Okay, so let's start the application. Okay, everything run fine. Order follows the same structure. Port first, but with a twist. So let's move to the order and create in the main package in orders order repository interface. So now void save order. Now we have two separate methods instead of one, find by ID, returning order. Use like that. For example, sender order and receiver order have different fields, different life cycles. Let's copy receiver order. Okay, here it's parcel ID or receiver order by parcel ID. Okay, so the caller knows which one they are looking for. Making them pick by casting a base type is worse. Now let's create the OrderJPA out persistence OrderJPA. So now we add the entity annotation, table name, for example, orders. Now in inheritance, in our strategy is in single table. One table for both order types, sender order and receiver order. Share most columns, order ID, parcel ID, sender, receiver ID, status. Receiver order adds 2 nullable columns, pickup code and locker ID. That is minimal divergence. 2 tables would just add joins for nothing. So now columns, name, order type, no args constructor and only getter. Okay, so now we add UID, order ID, parcel ID, sender ID, receiver ID, delivery options, status, created at. Okay, and here OrderJpaEntity and add from and return switch order. So if case is sender order S, then sender order JPA from and put S. Another case receiver order JPA from R. Nice, and we'll create the abstract method abstract order to domain. I forgot to add abstract here. ID. Okay, nice. Now let's create the sender order JPA and receiver order JPA entity. Okay, I create the receiver order JPA. We add descriptor value receiver from sender. I add the map deliver option mapper like that. So if we have locker delivery, so we set the delivery type into locker ID, locker slot ID, courier delivery, variables like here, and we need to add to our order JPA entity these variables like city, street, house number, apartment number. Okay. Now let's create the persistence adapter. Order persistence adapter. We implement order repository and add required as constructor and private final order. I forgot to add order JPA repository. So first create this one. Repository. Okay. JPA. Order JPA entity. ID. Okay. So save its JPA repository save and from order, of course. Here return okay. It's sender, so we need a filter. So instance of sender order JPA entity and map like that toDomain like that. Okay. Now, like in parcel configuration, we can copy this and paste in the order configuration, but we change to the order persistence adapter, order JPA repository. Okay, we can try to run our application. Okay, it's fine. Dependency arrows point inward. Use case depends on the port. Adapter implements the port. Nothing in the domain imports from the adapter. Annotation configuration wires it all together without either side knowing about the other. Parcel and Order have persistence ports. The use cases talk to interfaces, JPA, transactional, entity mapping, all adapter concerns. No one of it in the domain. From and toDomain live on the entities themselves. No separate mapper class, mapping logic stays close to the data it describes. Transactional is on the adapter. The full story is a separate episode. Linking in the description. Next episode, domain service. We have parser and locker as separate aggregate roots, but neither one can decide by itself which locker slot to assign. Someone has to coordinate that, and it is not a use case. It's a domain logic. That is what we are building. Code is on GitLab, branch part 3 repository, branch of it, open a merge request if you had approached it differently. I will read them. See you next time.